Hello guys. In the today lecture, I am going to continue from the my previous lecture. Okay. In the previous lecture, we have covered uh, till this till this line. Now I am going to cover from now onwards from this. Okay. Bagging works by creating multiple versions of the same model, each trained on a different random subset of the training data. You have to remember this statement. It would help you to help in interview to make understand your fundamental knowledge of this bagging. Okay, to understand the interviewer. Bagging works by creating multiple versions of the same model, each trained on a different random subset of the training data. You have to understand meaning of this sentence. Bagging works by creating multiple versions of the same model, each trained on a different random subset of the training data. Are you getting meaning of this sentence? Bagging works by creating multiple versions of the same model, each trained on a different random subset of the training data. Okay, bagging works by creating multiple versions of the same model. Okay, this is the you have to remember bagging works by creating multiple versions of the same model. Bagging works by creating multiple versions of the same model. You getting my point? Means bagging works by creating multiple versions of the same model, each trained on each model trained on a different random subset of the training data. Each model trained on different random subset of the training data. Feel it. I am revising it multiple times to feel the concept, not to avoid the mug of the concept. That is why I have been keeping I have been revising multiple times the same line. Bagging works by creating multiple versions of the same model. Creating multiple versions of the same model. Remember, creating multiple versions of the same model. Creating multiple versions of the same model. Bagging works by creating the same creating the multiple version of the same model. Are you getting my point? Means bagging. Once again, revise. Continue to sing as a song to get feeling of this sentence. Means bagging works by creating multiple versions of the same model. Each you have created multiple version of the same model. Means you have created three versions of the same model, each trained on a different random subset of the training data. Each trained on a different subset of the training data. Each trained on random subset of the training data. To remember this, each trained on a different random subset of the training data. Continue guys to revise with me so that you get feeling of this. Okay, and now this line says that by averaging the predictions of these multiple models, whatever the predictions made by these multiple models, we have to take average of their outputs that is written. This is the meaning of this. By averaging the predictions of these multiple models, bagging helps to reduce the variance. Bagging helps to reduce the variance. Bagging, it is written, bagging we are using to reduce the variance. We are using variance bagging to reduce the variance. Here written wagging. Here it is clearly written. Please follow my pointer cursor pointer. Bagging helps to reduce the variance of the model, making it less sensitive to small fluctuation in the training data. And by reducing the variance in the model, makes it less sensitive to fluctuation of in the training data. Means making it less sensitive to small fluctuation in the training data. Are you getting my point? Means making it less sensitive to small fluctuation in the training data. Making it less sensitive to small fluctuation in the training data. You have to keep continue this guys please. So that my only simple purpose is there to keeping multiple time revise so that you can understand the meaning of this sentence. Means making it less sensitive to small fluctuation in the training data. Once again revise, averaging the predictions of these multiple model bagging helps to reduce the variance of the model. Variance helps to reduce the variance of the model. Bagging helps to reduce the variance of the model. This is the cause effect of this, making it less sensitive to small fluctuation in the training data, making it less sensitive. If any fluctuation in the data is there, it is less sensitive. Okay, it is less sensitive if there any fluctuation in the data. It will not get impacted by the if fluctuation in data is there. This is the meaning reduction in the when we reduce the variance, that means model is not get impacted by the if we make little bit change in the data. Are you getting means? In another word, we can say that bagging reduce the variance. That means the import means implication of this implication of reduction and variance of the model is is the the is means if we change the little bit in data, the model don't get impacted influenced. It is less sensitive. It is less sensitive, make model less sensitive. Model makes model less sensitive. Okay, means this is the characteristics of the variance. Means reduction in the variance means model don't become less sensitive to the data. Means if any fluctuation in the data is there, that means next line. However, since each model is trained on a different subset of data, the bias of the model is not affected as it uses the same assumptions and relationships as the original model. Meaning, trying to understand meaning of this few few lines. Okay, means, however, since each model is trained on different subset of the data, because we have earlier in the paragraph was written we are using the multiple version of the same model, and for example we have created three model and we are providing a three model different subset of data, but here is telling now you have to connect those with this paragraph. Each model is trained on different subset of data. Okay, each model is trained on different subset of data. That means M1 model, D1 data, M2 model, D2 data, M3 model, D3 data. Are you getting? Once again, I revise. Since each model is trained on different subset of the data, that means model is trained on different subset of the data. That means each model is trained on different subset of data. Means M1 model, D1, M2 model, D2, M3 model, D3. The bias of the model is not affected. Bias of the model remain mostly the same. This is the meaning. As yesterday, I told you it is written here, bias roughly the same. Bias roughly the same. Yes, same. This is the same thing is written here. Means the bias of the model is not affected. Bias of the model is not affected. Bias of the model is not affected. Remember, guys, this line. This is the key points of this model. This is the crust of this model. Means bias remain the same as it used the same assumption and relationship as the original model. It is possible only when it uses the same assumptions and relationships for the original model. Okay, this result in a reduction of the variance while keeping bias of the model roughly the same. Whatever we have discussed above, this was the cause. Effect of this that cause is reduction of the variance while keeping bias of the model roughly the same. Means variance while keeping bias model roughly the same. Reduction of the variance while keeping the bias of the model roughly the same. Okay, means this result in a reduction of the variance. This means reduction in the variance. This means this result in the reduction of the variance while keeping voice of the model roughly the same. Keeping voice of the model roughly the same. Keeping voice of the model roughly the same. Are you getting my point? You have to connect this means the results in a reduction of the variance while keeping the bias of the model roughly the same. You have to connect my points that result in a reduction of the variance and the variance in the variance and roughly keep the variance keeping the bias roughly the same, helping to find a balance between underfitting and overfitting. That means it helps it helps to balance between underfitting and overfitting. It helps keep for keeping balance between underfitting and overfitting. Are you getting? It helps. It helps in keeping balance between overfitting and underfitting. Is written. Let's move to next page. Next is random forest. Okay, here random forest means bagging, boosting. Bagging in random forest means bagging is the bootstrap aggregation. Bootstrap means is a type of sampling group of trees. Random forest means group of trees. Whenever we talk about random forest, it must click in your mind. We, we are talking about the trees. We we are talking about the trees. Okay, random forest. Whenever someone asks someone to you about random forest, that is means it first you have to tell them group of trees. What group of trees? Group of trees. And this is the decision trees. Means group of decision trees. Group of decision trees. Then bagging. Then bagging. Then bagging. Then bagging. Then bagging. Then bagging. Bagging means bootstrap aggregation. Bootstrap means sampling. Means you have to remember this little blog. It helps you to define all the concept about the random forest. Okay, means random forest is a bagging. Example of bagging. Example of bagging. Example of bagging. Bagging means bootstrap plus aggregation. Bootstrap plus aggregation. And bootstrap means sampling. And this is the random group of decision trees. Let's move to next. It is a bagging technique where all base models are decision tree. This is the remember in interview the interviewer asked base model. So base model in this is decision tree. Base model in this decision tree. Base model in this decision tree. This is you have to remember. It is a bagging technique where all base models are decision tree. It is a bagging technique where all base models are decision tree. It is a bagging technique where all base models are decision tree. It is a bagging technique. It is a bagging technique. It is a bagging technique where all base models are decision tree. Where all base models are decision tree. It is a bagging technique. It is a bagging technique where all models are where all base model are decision tree. Okay, keep revising with me. It is a bagging technique. It is Which kind of technique? Bagging, where all base model are decision tree. Where all base model are decision tree. Okay. Data set here. This is the block diagram is given. Let's try to understand it. Data set. This is data set D1, D2, D3, and Dn. And data set we can make by row sampling, column sampling, and combination. Row sampling, column sampling, or next is combination. Okay, remember data set. It is a row sampling, column sampling, combination. Row sampling, column sampling, and combination. Here, D1, D2, D3, these are the different data sets for decision tree 1, decision tree 2, decision tree 3, decision tree 4. Okay, here, here average all predictions. We take average of all the predictions. We take here average of all the predictions. We take here average of all the predictions. Okay, are you getting? Yeah, means data set we can make by using row sampling, column sampling, or combination. Three options are available. That different model, different data. Decision T1, data D1. Decision T D2, data D2. Decision T3, data D3. Decision T Dn, data Dn. Okay. And next, average all predictions. Okay. Now, some key points are written here. Try to read. Now, read. Two characteristics of the random forest allows a reduction in the overfitting and the correlation between the trees. Means we have to remember this point. Two characteristics, and definitely we share which are the those characteristics. Means two characteristics of random forest allows a reduction in the overfitting. Reduction in overfitting, not underfitting. You might get confused in the interviewer in the front of interview overfitting and the fitting. So you have to remember overfitting, reduction of overfitting, and the uh, and the actually and the correlation between the T and the correlation between the T and the correlation between the T correlation between the T correlation between the T means correlation between the T correlation between the T means two characteristics of the random forest allows a reduction in the overfitting and correlation between the T. Two things got reduction. First, overfitting and correlation between the T means overfitting and correlation between the T. Correlation and reduction of the T. Correlation and correlation, and overfitting, overfitting. You have to keep revising these things. Mean two characteristics of the random forest allow a reduction in the overfitting and reduction in the correlation and the overfitting. Two characteristics, which are the those characteristics? Could you share? I definitely share. Wait, a, wait for a while. I, I would share two characteristics of random forest allows a reduction in overfitting and the correlation between trees. Next, first is bagging. First is the two out of two, one is bagging. Out of two, one is bagging. Out of two, one is bagging. One is bagging, where individual decision trees are fitted following each bootstrap sample and then averaged off, then averaged afterward. Remember this line. First is bagging, where individual decision trees are fitted. First is bagging. First is bagging. First is bagging, where individual decision trees are fitted. 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 Keep revising. Keep revising, please. Means first technique is bagging, where individual decision tree are fitted following each bootstrap sample, following each bootstrap sample, following each bootstrap sample and averaged afterward, and averaged afterward, and averaged afterward, and averaged afterward. Okay, okay, means first is bagging, where individual decision trees are fitted following each bootstrap sample and then average afterward. First is bagging, first is bagging, first is bagging, where individual decision trees are fitted, where individual decision trees are fitted following each bootstrap sample, following each bootstrap sample and then average afterward. Next, bagging significantly reduce the variance. Bagging significantly reduce the variance. Which technique? Bagging significant the variance. Which thing it reduce significantly? It reduce variance. Bagging significantly reduce the variance of the random forest versus the variance of any individual decision tree. Bagging significantly reduces the variance of the random forest versus the variance of any individual decision tree. Try to connect it. Bagging significantly reduces the variance of the random forest versus the variance of the individual decision tree. Are you getting my point? You have to connect with it. Bagging significantly reduces the variance of the random forest versus the variance of any individual decision tree. Okay, bagging, bagging, bagging significantly reduces the variance of the random forest versus the variance of the individual decision tree. Next things, the second way, first is tagging and second is random forest reduces the Overfitting is that a random subset of the features is considered at each split, preventing the important feature from always being present at the top of the individual trees. Okay, you have to remember this point. What does it mean? Okay, you have to remember meaning of this. It definitely help you to understand. Yeah, the second way, random forest reduce overfitting. Random forest reduce overfitting. Random forest reduce overfitting. Random forest reduce overfitting is that a random subset of a random subset of features, a random subset of feature, 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 a random subset of features. A random subset of feature is considered at each split. A random subset of feature is considered at each split. We have to keep this point. Means a random subset of features is considered at each split. A random subset of features is considered at each split. Once again, second way, random forest reduce overfitting is that a random subset of feature is considered at each split, preventing preventing the important features from always being present at the top of the individual trees, preventing the important features from always being present at the tops of the individual trees. That means preventing the impression features from always being present at the tops of the individual trees. Means preventing the important features from always being present at the top of the individual trees. Preventing the important features. What important features from always being present at the tops of individual trees. Okay. Now next is out of bag evolution. Out of bag evolution. Out of bag evolution. Next is I'm going to cover out of bag evaluation. While doing row sampling, feature sampling, while doing row sampling or feature sampling means column sampling with replacement for each for each model, so there is a chance that some set of values may not get selected. Okay, first understand the meaning so that you get idea. While doing row sampling or column sampling with replacement for each model, so there is a chance that some set of values may not get selected. It is observed that nearly 37% of the data not selected. Okay, we can use that unselected data points for testing and validation purpose. Okay, next, if you set out of the bag. If you set out of the bag equal to true, then it will automatically handle missing data points for testing purpose. Okay, if you set out of the bag true, that means it will automatically handle missing data points for testing purpose. Means if you set out of the bag means to it will automatically handle missing data points for testing purpose. Okay, then it will automatically handle missing data points for testing purpose. Okay, you have to remember this. Means true. It will automatically handle missing data points for testing purpose. Okay, if you set out of bag true, that means it will automatically handle missing data points for testing purpose. What is the difference between out of the bag score and validation score? Since we have understood how bag of how out of bag score is estimated, let's try to comprehend how it differ from the validation score. Try to focus. As compared to the validation score, out of bag score is computed on data that was not necessarily used in the analysis or model. As compared to the validation score out of bag score is computed on data that was not necessarily used in the analysis or model. Try to understand the meaning of this line. As compared to the validation score, out of bag score is computed on data use that was not necessarily used in the analysis of the model. Whereas for calculation validation score, a part of the original training dataset is actually set aside before training the model. Whereas for calculation of validation score, a part of the original training dataset is actually set aside for training the model. Additionally, the the bag of word score. Additionally, the bag of out of the bag score. Additionally, out of the bag score is calculated using the only subset of decision tree not containing the bag of out of the bag sample in their bootstrapping dataset. While the validation score is calculated using all the decision tree of the ensemble. Let's try to understand the meaning. Additionally, the out of bag score is calculated using only a subset of the decision tree, not containing the out of bag sample in their bootstrap training dataset, while the validation score is calculated using the decision tree of the ensemble. Okay, and in the ideal case, about 36.8 of the total training data forms the out of bag sample. This can be shown as follows. This is the proof you can check. Okay. Thank you guys. If you have any queries regarding this lecture, what I should include. Okay.